So guys, I'll not be teaching you mixed strategies. Our example first is about Battle of the Sexes. ये वही एग्जाम्पल है जो मैंने आपको प्योर स्ट्रैटेजी में भी कराया है. सो इफ यू वांट टू डू प्योर स्ट्रैटेजी यू कैन वॉच माय अर्लियर वीडियो एज वेल. Now, the rules are that both wife and husband are planning to have a date together on the coming weekend. Wife would love to go to ballet, whereas husband likes to go to boxing match. The main condition is that they both should be together. Now, guys, in order to solve this particular question, I will first make a payoff matrix for you, and then I shall be teaching you how to solve a mixed strategy Nash equilibrium under a game theory. So, let's see the payoff matrix first. Guys, now I have this payoff matrix, though you should not be using it while having a mixed strategy question, but I have prepared it just to make sure that you know the final outcomes. See, player 1 is wife, player 2 is husband. Now, wife has got two strategies up her sleeves. She can go to ballet or boxing. Same with husband, ballet and boxing. Now, if they both go to ballet, wife is going to get 2 points for it, whereas the husband is going to get 1. Why? Because husband, at least he is with, his wife. But when it comes to wife, she's going to get 2 points because A, she is with her husband, and B, she is actually going to her preferred place, that is ballet. Ballet, boxing, they are not together, 0-0. Boxing, ballet, they are not together, 0-0. Boxing, wife 1, husband 2. Because wife is still with her husband, that is why 1. Husband, not only she's having his wife with her, with him rather, and also he's going to watch a boxing match, which he loves so dearly. So, how to solve a mixed strategy question then? Well, guys, first of all, you need to do one thing. I'm giving you a shortcut sort of thing. First and foremost, what you need to do is, this is husband, this is wife, this is h1 minus h, this is small w, 1 minus small w. Now, what are these? Well, this small h is the probability of husband going to ballet, and 1 minus h is the probability of husband going to boxing. Similarly, this small w is the probability of wife going to ballet, and this 1 minus w is the probability of wife going to boxing. Now, with this, I shall be telling you how to solve this mixed strategy Nash equilibrium. Guys, first and foremost, you need to write this. This is called expected payoff of wife from ballet. So, you've got to be very, very sure what you are doing. Expected payoff of wife from ballet. Well, guys, if I see it, wife has committed that she's gonna go for ballet. Now, what will be her expected payoff shall depend largely on what the husband does. Suppose husband also goes to ballet, the probability of which is pi. So, wife is gonna get 2, right? But if the husband is going to boxing, the probability of which is 1 minus h, the wife is going to be ending up with a 0. So you have this as 2h. If you guys are not comfortable with this, go to your third semester economics, where you would find that the expected payoff stands for pi 1 n1 plus pi 2 n2 is equal to 0. Remember that pi was the probabilities and n1 and n2 are respectively the final outcomes. So the same thing I have used here. So guys, expected payoff of wife from ballet is then h, that is probability of husband going to ballet, and if that happens, wife is going to be ending up with 2. And if the husband goes to boxing, the probability of which is 1 minus h, the wife is going to get a 0 because she is going to ballet and the husband is going to boxing. Now, you will write expected payoff of wife from boxing. So now suppose she has committed herself that she's gonna go to watch a boxing match. Now, what will be her average payoff, expected payoff? That shall depend upon what the husband does. So if the husband goes to ballet, the probability is h, wife is gonna get 0. If the husband goes to boxing, the probability is 1 minus h, well, the wife is gonna be ending up with 1. So guys, solve it and you have this 1 minus h. Now, you need to make wife indifferent among these two expected payoffs or these two outcomes. In order to do that, write 2h is equal to 1 minus h, and you have h as 1 by 3. What is the use of this h is equal to 1 by 3? I shall be teaching you that very shortly. Now guys, I'm going to do the same thing from the point of view of husband. Now you will write husband's expected payoff from ballet. Now here we have assumed that the husband has committed himself to go to ballet. Now what will be his expected payoff shall depend upon what the wife does. Now if the wife also goes to ballet, the probability of that is W. Husband is gonna get a 1. If she goes for boxing, the probability is 1 minus W. He's gonna be ending up with 0. Solving it gives us W. Now what shall be the husband's expected payoff from boxing? Well guys, husband's expected payoff from boxing shall depend upon what the wife does. Suppose wife goes to ballet, the probability is W, husband ends up with 0. Suppose the wife goes to boxing, probability of which is 1 minus W, husband is gonna get 2. Solving it leaves us with this 2 minus 2W. Now again, just like we did in the case of wife, we have to make this husband indifferent among these two possible outcomes or the possible values of expected payoffs. Doing that shall give us this. So we have this W is equal to 2 by 3. Now mera bacha, you need to understand certain aspects about this. First, in pure strategies, you can have any number of Nash equilibriums. When I say any number, it means even, odd, or any number. But when it comes to mixed strategy, the answer shall always be in terms of odd. So for example, if solving pure strategy, you have 2 Nash equilibriums. In mixed strategy, you will end up with 3. But if you are solving a pure strategy Nash equilibria and you are finding it that there is only 1 Nash equilibria under pure strategy, then mark my word, under mixed strategy also you will be ending up with 1. Now getting back to this particular example, battle of the sexes. Well guys, when we solve battle of sexes under pure strategies, you would find that there were 2 Nash equilibriums, ballet and boxing. So going by the words जो भी मैंने आपके साथ डिस्कस किए, अंडर मिक्स स्ट्रेटजी वी विल बी हैविंग 3 नैश इक्विलिब्रियस. हाउ, आइए मैं आपको दिखाता हूं और मैं आपको दिखाता हूं कैसे इसका रिएक्शन कर्व हम शो करेंगे. वेल गाइस, दिस इज आल्सो नोन एज बेस्ट रिस्पांस फंक्शन. This is W, this is H. This W is actually the wife's probability of going to ballet. This H is husband's probability of going to ballet. Now guys, I am writing 1 by 3, 2 by 3, 1, 1 by 3, 2 by 3 and 1. Now guys, please focus. Well, you had H as 1 by 3 and W as 2 by 3. So this, my dear friends, shall be considered as your first Nash equilibria under mixed strategy. Now, this shall be considered as another Nash equilibria. Just have a look. 1 and 1. 1 is what? Wife's probability of going to ballet 1. That is 100%. H, husband's probability of going to ballet 1. That is 100%. So that actually tells us that both wife and husband are actually going for a ballet. So this Nash equilibria shall be that one, ballet, which we actually did in the pure strategies as well. What about 0, 0? Well guys, W being 0 means that the probability of wife going to ballet is 0. That means probability of wife going to boxing is 100%. Same here. 0. H is 0. Well, H was the probability of husband going to ballet. Now, don't you think so? If H is 0, that means 100% probability of husband is, he is going to a boxing match. So this again is your third Nash equilibria. This will be about boxing and boxing. So ballet, boxing, 2 Nash equilibria from pure strategy, and these values which you have found of W and H respectively shall be the third Nash equilibria which you have found out in the mixed strategy. Now I'll be talking about best response functions. Well guys, you need to be street smart here. Suppose the probability of wife going to ballet, that is W, increases. Now what should be the response of husband? I guess he should also increase his probability of going to ballet. because ballet is what they are looking for in order to have a Nash equilibrium. Similarly, if the probability of husband, I'm showing like this, the probability of husband going to ballet, that is H, is increasing, don't you think wife's probability of going to ballet should also increase? So this should go like this. So these are best response functions, my dear. So as the name suggests, best response. You observe, you watch the other player, what he's doing, and then you do your own act. In this case, if the probability of going to ballet is increasing by one player, the other player should also increase his probability of doing the same. And the same holds true if the probability of going to ballet falls or the probability of going to boxing rises. अभी हम और भी एग्जांपल्स आपके साथ डिस्कस करेंगे. आप ध्यान से कीजिएगा, जो मैं आपको शॉर्टकट बता रहा हूं, मिक्स स्ट्रेटजी आपको सारे इसी तरीके से सॉल्व करने हैं. So guys, now I have my second example. We have two players, with player 1 having strategies of being up and down and player 2 is having two strategies of going left or right. I will now be showing you the payoff matrix and then how to solve it. So guys, we have a payoff matrix now. Player 1 having two strategies up and down and player 2 is also having two strategies of left and right. And we have some values too. So in this question, we are here to solve a pure strategy Nash equilibrium and then a mixed strategy Nash equilibrium. So first, I'm going to start with the pure strategy. When I'm writing this again for you guys. So this is player 1 having strategy of up and down, player 2 having strategies of going left and right. Now with these values 4, 1, 0, 0, 0, 0 and 1, 4, let us solve it for pure strategy. Suppose player 1 assumes that player 2 is gonna go left. Player 1 assumes that player 2 is gonna go left. Now he has to decide up and down, up and down, up and down, up and down. I guess up. Now if player 1 thinks that player 2 is gonna go right, he has to decide up and down, up and down, up and down. Well, down. Now reverse this game. Player 2 now thinks that player 1 is gonna go up. Player 2 has to decide left, right, left, right, left. Now suppose player 2 thinks that player 1 is gonna go down. Player 2 has to decide left or right, left or right, left or right. Well, right. So in this case, pure strategy Nash equilibrium, we have got two. That is up and left and down and right. That is this one and this one. So we have two Nash equilibrium in this particular question when we are solving it for a pure strategy. Guys, now I'm going to solve this question with mixed strategy. Please, I would request everybody here to be a bit careful. First of all, do this. We have got two players, player 1 and player 2. And they have got two strategies respectively. Well, player 1 has two strategies going up or down. And player 2 has again two strategies, either going to left or going to right. Now guys, we will assume that this player 1's probability of going up is say P and going down is 1 minus P. You can choose any alphabet. Player 2's probability of going left is say Q and going right is 1 minus Q. Now please be careful, see what I am doing. If you can catch this, you will be able to solve mixed strategy Nash equilibrium very convincingly. Now suppose the first thing is we write expected payoff of player 1 from up, or rather from going up. So guys, here we have assumed that player 1 has committed himself that is gonna go up. So what will be his expected payoff? In that case, his expected payoff shall depend upon what the player 2 does. Now, if the player 1 goes left, the probability of which is Q. So, if he goes left, he's obviously going up. Please read this. He's gonna get 4. Please see, expected payoff of player 1 from going up. So, player 1 has committed himself to go up. Now, what is his expected payoff shall depend upon what the other player is doing or he's gonna do. So, if the other player is gonna go left, the probability of which is Q, this player 1 is gonna be ending up with 4. But if the other player is going right, the probability of which is 1 minus Q, then what this guy is, the player 1 is gonna get, because he has committed himself to go up, he'll be getting a 0. I repeat, he'll be getting a 0. So that's what I write. So you solve it and you get a 4q. Now do this thing. Write expected payoff of player 2 or rather player 1 from going down. So now he has committed himself to go down. Now his expected payoff from going down shall depend upon what the player 2 does. So if the player 2 goes left, the probability of which is again q. So if he goes left, this player 1 has committed himself to go down. If the other player 2 goes left, what he's gonna get? A 0. Now if the second player goes right, my dear friends, the probability of going right by player 2 is 1 minus q. So player 1 who has committed himself to go down, what he's gonna be ending up with? I think he is going to get a 1. So you solve it, 1 minus q. Now guys, you have to make this player 1 being indifferent from going up and down. So for that, write 4q is equal to 1 minus q, and guys, you have q as 1 upon 5. So we're gonna repeat this same exercise, or same thing with respect to player 2 now. So ध्यान से देखिए, it's very important. Now guys, we should be solving the same thing, but this time from the point of view of player 2. So I'm writing expected payoff of player 2 from left, that is from going to left. Now don't you think his expected payoff of from going left shall depend upon what the player 1 does. So suppose player 1 goes up, the probability of which is p. So now read this payoff. So this guy has committed himself to go left, and player 1 suppose goes up. So what he's gonna get is a 1. But if the other player, that is player 1, goes down, the probability of which is 1 minus p, what this guy is gonna do who has committed himself to go left, I think he should be getting a 0. So it's p. So I repeat again, expected payoff of player 2 from left. So player 2 left. Now how much will be his expected payoff shall depend upon what the player 1 does. If the player 1 goes up, the probability of which is p. So don't you think this player 2 is gonna get a 1. But if the player 1 goes down, the probability of which is 1 minus p, is gonna get a 0. Now what we write is expected, I repeat, expected payoff from, or rather of player 2 from, say, going to a right. Pardon me for this bad handwriting. So expected payoff of player 2 from going right. Now don't you think he has committed himself to go right? So his expected payoff now again shall depend upon what player 1 does. So player 1, if he goes up, that is the probability p. Player 2 is gonna get a 0. Now if the player 1 goes down, the probability of which is 1 minus p. Now don't you think guys, he has committed himself to go right. Player 1, if he goes down, the probability of which is 1 minus p, what the player 2 is going to be ending up with is 4. So you've got to be really smart in understanding this payoff matrix and using it. So that is the key here. So now you solve it and you get this 4 minus 4p. Now guys, again you've got to make this player 2 indifferent between using left and right. For that you keep this equal and you get your p as a 4 by 5. Now I shall be teaching you guys about the best response functions as well. But before I do that, remember this same game had 2 Nash equilibriums when we solved it for pure strategy, and now those 2 will be there, but along with that we have got 1 more Nash equilibria, that is in total 3 Nash equilibria under mixed strategy. The 2 of those will be the pure strategies one, and the third one will be these values where Q is 1 by 5 and P is 4 by 5. Now I shall be teaching you in this particular question how to draw best response curves. Now guys, be very smart, because if you can understand this particular thing, you should be winning this mixed strategy topic. Well guys, if you remember, Q was 1 by 5 and P was 4 by 5. Now, so going with that, this should be your Nash equilibria जो आपने mixed strategy में solve किया. But now यहाँ पर एक catch है. आपको पीछे जाना होगा, आप देखेंगे आपका जो pure strategy का Nash equilibrium था, मैं यहाँ लिख देता हूँ. प्योर स्ट्रेटेजी का जो नैश इक्विलिब्रियम था, दैट वाज अप एंड लेफ्ट, माइंडेड अप एंड लेफ्ट, एंड जो दूसरा था बच्चों, और वो था डाउन एंड राइट. So you've got to be smart here, really smart, because ये battle of sexes से opposite लिया गया example deliberately. So best response function इस पे कैसे समझना है हमको? एक बात सोचिए, P क्या है? Well, P है probability of player one which is going up. And Q क्या है? Well, Q is the probability of player 2 about going left, right? सबको हम ये clear कर रहे हैं? P is the probability of player 1 of going up and Q is the probability of player 2 of going left. So please be smart here. Now suppose, I repeat, now suppose the probability of player 1, that is P, which is going up, is increasing. Which is going up is increasing. So it's like this, it is increasing. Cool? So if you know that your Nash equilibrium was up and left, and my dear friends, this Q was actually the probability of, going to left. So it should look something like this. So if this increases, that is probability by player 1 of, it is increasing of, going up. So the other player, the best response should be to increase his probability of going to left, because that was one Nash equilibrium. Now suppose if the probability, I repeat, if the probability of this player, the first player is, P is decreasing, that is his probability of going up is decreasing. In other words, his probability of going down is increasing. So if the probability of going down is increasing, or in other words, if P is decreasing, don't you think the other player, that is player 2, should increase his probability of going to right? See, get it? And going to right was 1 minus Q. So how to get this again? See, if you see P is decreasing, that means you'll be coming like this, because P is decreasing. P is what? P is players 2's probability of going to left. So if that is decreasing, that means P is decreasing, that means 1 minus P is increasing, that is going down is what this player 1 is seeking. So best response function for player 2 in this scenario should be to go for right, because that was the Nash equilibrium, right? So guys, Q was the probability of player 2 of going to left. Now, seeing what the other player is doing, he should also act accordingly. And in this case, since the Nash equilibrium was down and right, the other player should increase 1 minus Q. That is, he should also go down. If he was here and he was here. So you've got to be smart. See, you plot these points, great. But then when it comes to having those best response function, you need to go to your pure strategies Nash equilibrium and then decide what should be done. So in this case, if P rises, that is up. Q should also rise, that is left, because that was one Nash equilibrium. If P falls, that is 1 minus P rises, that is going down. Then other players should go to right, and by going right means 1 minus Q should be increased. In other words, Q should be decreased. So I hope this helps, and we shall be dealing with many other examples very shortly.